I guess, should I be paying Nike this royalty fee, or should they paying me? Because I'm advertising them. Oh well. Okay, so u sum, let minus y squared, let me use a different color, I'll go red. I'll go u equals minus y squared, du equals minus 2y dy. So here's my y dy, which is what I have here. Okay, so then y dy is equal to minus 1/2 du, and so this is equal to 2 pi. Okay, I'm not going to change my limits here right now. Okay, we'll worry about it in a minute. So what I have is y dy is minus 1/2, so it's going to be minus 1/2, and then I have e to the u du. Okay, and please do not put your limits as 1 and 0, because that's not what that variable is. Okay, the variable is u, which is related to y here. Okay, so strictly speaking, you want to put y equals 1, so you get the upper limit would become minus 1. Okay, let me erase this. Okay, put in the new limits now. It's up to you whether you want to do the new limits here, or yeah, let's just go do that. Okay. So what did I say? I said I'm going to put y equals 1, so u becomes negative 1. And then I'm going to put y equals 0, so u equals 0. Okay. And I'm going to use the properties that I'm going to reverse these limits here. I stick a negative sign, so that negative sign and that negative sign will cancel, the 2 and the 2 cancel. So I'll get pi, and it will be going from minus 1 to 0, eu du. JDI this, you get pi eu 0 to minus 1, which gives you pi is 1 minus 1 over e. And so your final answer, depending how you want to write it, you can write it like this, or you can give me a decimal answer for that. Okay, give me a decimal, plug and chug. I'm going to pause here and make sure that this answer is correct. Right, so that answer was indeed right. Okay, so the answer is pi 1 minus 1 over e. All right, do we have one more example to do? I think we do. I'm going to pause here. So the last example in this section is actually doing this previous problem that we just did using the shell method instead using the disk method. Okay, so that's an alternative way of doing it. And I just wanted to I did this just so that you can compare and see how one method can be easy in certain situations and the other method difficult. So here is the solution for the problem that we just did. Okay, I'll let you copy this, get it down, and then I'll go over it. Okay, I'll go over it. I hope you can kind of read this. So the equation that the graph that we have, like I showed you earlier, okay, is this yellow region here, and in here it's obtained by did I snip this? Okay, let me snip. Okay, I got that. Okay, it's a region formed by these points here. Okay, so really it's this region here. Okay, and we are now rotating it about the x-axis. Remember, in the shell method, we were rotating it about the x-axis as well, and our representative rectangle was horizontal. Now we are doing the same thing. Okay, we are still rotating it about. Where am I? We are still rotating it about the x-axis. Okay, and the region that we are working on is this yellow region here. Okay, and we're going to rotate it about the x-axis as shown here. Okay, shown there. All right. Let me just kind of trace the outline of the region so you can see what's going on here. Okay, So this curve here, where this arrow is pointing, is x equals e to the minus y squared. And since we are rotating it about the x-axis using the disk method, okay, our representative rectangle is going to be vertical at right angles to the x-axis. So here's my representative rectangle. Okay, and it gets rotated about the x-axis. Now notice that in order to really generate the volume, I have to break it up into two pieces, because the one piece that I have is really for this region here, okay, this region here. Okay, so for that region, okay, and you can see that what it's going to be is it's just going to be a cylinder. Okay, so that's what I have, volume 1. Although I've done this using calculus, we could have easily done this using pure geometry. Okay, pure geometry. So using the disk method, my radius is 1. Okay, my radius is 1. That's this height here. Okay. My height of the cylinder is 1 over e, because that's the point that I get when I put y equals 1 here. Okay, because the y coordinate here is 1, as you can see. So then x would be equal to e to the minus 1, which is 1 over e. That's where this limit comes from. That's where this limit comes from. Okay. So the volume of the first region, the yellow region that I show you here, is just pi over e. It's pi over e. Excuse me. And we could have gotten this from pi r squared h. Okay, no big deal. Pi r squared h. R was equal to 1, and h is 1 over e, and would have given us the same answer here. Okay, that's pi r. Then there's another region that I need to do. Okay, there's another region that I need to do, and that is this region here, which is now between a curve. Okay, and the curve is given by the equation x equals e to the minus y squared. Okay, and if I take the inverse of that, okay, if I take the inverse of e to the minus y squared, just take ln's on both sides, then my curve actually becomes y equals square root of negative ln x. Okay, all right. So taking the representative rectangle to be this, okay, taking that to be the representative rectangle, okay, the radius is y, which is given by this, okay, the width of the disk is dx, so my volume of disk is going to be pi y squared times delta x, so dx, which is equal to pi minus ln x dx, or delta x, whatever you choose. Okay, and so I need to integrate that, and if you look at it, that's what I've done here. That's what I've done here. Okay, and the limits are going to be from 1 over e, which is right there, to x equals 1, which is right there. Okay, because x equals 1 is obtained by putting y equals 0 in this equation here. Right. Now if you take a look at this integral, it becomes equal to minus pi from 1 over e to 1 ln x dx. Haven't learned that? Don't have a clue as to how to do that. So the only way you can do this is going to do calc number 7. Okay, calc number 7. So I'm just going to tell you where it is just to show you. Okay, so you're going to go number 7 here, do fx dx. You're going to put ln x and y1, and then just do it. So you can see that you could have done this problem using the disk method, but man, is that more difficult than the shell method? I mean, if you had no graphing calculator, there's no way you could do this. There's no way you could do this. All right. So there in that example illustrates the power of the shell method. And of course, there are cases where the disk method is better. So you take your poison. Comparison of disk method and shell method, page 469. Please review this. Make sure you understand that. Okay, so let's go to page 469. Actually, I'll just scroll down. Okay, so here's a comparison of the disk and shell methods. So just to review quickly, you can see that the first two diagrams here are your disk method, axis of revolution. Here is the y-axis, so your rectangle is going to be horizontal. Here your axis of revolution is the x-axis, so your rectangle is going to be vertical. And here's your shell method. Axis of revolution is the y-axis, rectangle is parallel to the y-axis, and here axis of revolution is the x-axis, rectangle is parallel to the x-axis. Now the things to notice for the shell method particularly, and actually you have the same sort of things going for the disk method. For the shell method, P represents the distance or the midpoint of the rectangle from the axis of rotation, and H is the height of the rectangle. Coming into the shell method, okay, R is the radius is the radius. How do we describe this? Well, take a look at the picture, see it for yourself, know how to do it. That's it. Bye.